So in dual nature, we will see about the dual nature of light and electromagnetic radiation and all. So in 1905, Einstein came up with a groundbreaking idea that that is the electromagnetic radiation has a dual nature, light wave nature and particle nature. So light has a dual nature, particle and wave nature. How we differentiate means in some situations the phenomenon exhibited by the light can be explained by wave nature phenomenon, and in some situations the light characteristics are explained by particle nature. So the particle nature can be explained by effects like photoelectric effect and black body radiation, whereas the wave nature can be explained by the effects like interference and diffraction. So diffraction is nothing but when light of comparable wavelength compared to the any obstacle, the light deviates from its original path or straight line. This is the bending nature of light. We can say it is a diffraction. And interference, in wave optics, that light travels through double slit, it interferes and produces constructive and destructive interference. This is the interference effect. These are explains the wave nature of the light. Then particle nature. So we know when we stand in a sunny day for a school prayer, we get that food got hot. So because how it comes, because when the nature of the black body, so a black body absorbs all light. It absorbs all light and emits us heat radiation inside it. It doesn't reflect in contrary to the white surface of the body. So that is the black body radiation. And photoelectric effect. Photoelectric effect is nothing but emission of electrons from the cathode or negative electrode to produce a photocurrent or to produce any current like a solar cell, photo cell, like that. Or we will explain that photoelectric effect in future slides. So coming to electron emission. So how electrons are emitted? So electron emission can be done by three ways. First is thermionic emission. Thermionic emission means by applying heat energy into a metal, the electron can be emitted. The heat energy is absorbed by the electron, and the electron can be emitted from the metal permanently. So electrons, electrons are revolving around the nucleus. It always binds to the nucleus. There is a binding energy, attractive energy between the nucleus positive charge and the electron negative charge. The electron when it has the maximum energy means the electron when it is free, the free electron has a maximum energy compared to electron binding with the nucleus. So in the sense of shells, so the K element shell, the K shell has the electron. If the K shell has electron, the electron has least energy compared to the M shell. Okay, so if electrons are far away from the nucleus means it has more energy compared to the electron near the nucleus because of the attractive energy. So thermionic emission means by applying heat energy we can emit electrons from the metal or atom. And field emission, by applying a strong electric field we can emit electrons from the atom or metal. Then photoelectric emission. Photoelectric emission, we know that I already said, by using light, by imparting the light energy to the electron can be emitted from the metal or cathode. In the photoelectric effect means we will discuss about the cathode and anode. So coming to photoelectric effect. So photoelectric effect means when incident light of particular wavelength incident on a cathode, that is a negative electrode, the electrons are emitted, which is called photoelectrons, and it is collected by the anode, and these electrons are flows through the emitter and battery and again to the cathode. This is called photoelectric effect. Here the cathode is a negative electrode and the anode is a positive electrode. So light should be a comparable wavelength, that is a smaller wavelength than the work function wavelength. We will see it in detail. So light should be have smaller wavelength or larger energy or larger frequency incident on a cathode, and electrons are emitted. The emitted electrons are collected by the anode. So it creates a potential difference and produces a current that is called photocurrent. So Einstein came up with an idea of light dual nature. He also proposed the equation for this photoelectric effect. What he said is energy of the incident light E equal to h nu. Incident light means the light has a package of particles according to quantum theory. The package of particles has photons. Each photon has energy E equal to h nu. So the energy of incident photon E equal to h nu is distributed as in two ways. Work function and kinetic energy. Work function means the minimum energy required to emit an electron from the cathode or emit an electron from the metal. It is always constant for a particular metal. Okay, work function is constant for a particular metal. If you take a metal like germanium, silicon, it is an alkylide. If you take a metal, sodium, photosensitive materials or any substances, work function is constant for a particular material. So if energy must be greater than the work function to emit an electron. So this is the basic criteria for photoelectric effect. Energy, given incident energy must be greater than the work function of the metal, or incident frequency must be greater than the threshold frequency. work function means h nu naught, that is nu naught is the threshold frequency, or we can say hc by lambda naught. Lambda naught is the threshold wavelength. So the incident energy must be greater than the work function for emission of photoelectrons, or we can say incident frequency must be greater than the threshold frequency. In other ways, the incident wavelength, the wavelength of the incident light must be smaller than the threshold wavelength. So you should not confuse the wavelength and energy and frequency, because energy is inversely proportional to wavelength and directly proportional to frequency. If energy increases, frequency increases. So the energy of the incident must be greater than the work function to provide the necessary energy to emit an electron from the cathode. So the given incident light's energy is distributed as work function. Initially we have to emit or overcome the binding energy of the nucleus, binding attraction energy of the nucleus to emit an electron. So we emitted an electron. The remaining energy goes for increasing the speed of the electron to attain the anode as fast as possible. So this is called half mv square, that is kinetic energy. So the energy of the incident light is distributed as first work function and the kinetic energy. So if you increase the energy, what will happen? Because we know phi naught, that is work function, is always constant for a particular metal. So when we increase the incident energy, it will always goes to increase the kinetic energy. So increasing the incident energy or increasing the frequency, it always increases the kinetic energy, that is the speed of the electron. So if we increase the speed of the electron, if we have to stop, means we should apply some negative potential to the anode. We know anode is a positive potential to collect all the electrons. So if we apply negative potential to the anode, it will repel the electron and stops the photoelectric current production. So if we apply negative potential to the anode, it is called stopping potential, retarding potential or stopping potential. The maximum potential required to stop all the electrons, that is the fastest electron. Even to stop the fastest electron, the required potential is called stopping potential. So if we increase the incident energy, the kinetic energy increases, the electron gets speeder, and we have to stop the stopping potential is much greater. So half mu square maximum equal to ev naught. So this is the formula to stop the maximum speeded electron, that is fastest electron or maximum kinetic energy electron. We should provide energy of ev naught, that is stopping potential into electron charge, that is in joules. So this is the equations mainly used for solving problems. So you should aware in solving problems, you should aware that what is the units and all. So all SI units are in joules. For energy, SI unit is joule, not what is same SI unit but not electron volt. So you should convert electron volt to joule in all problems, then only you have to get the correct answer. Then coming to variation of photoelectric effect due to incident energy and potential given to the anode and intensity. So intensity is nothing but the number of photons emitted or number of photons per unit area in given time. So if number of photons increases, means number of electrons emitted also increases, provided the basic criteria work function must be less than the incident energy, or incident energy lights incident lights energy must be greater than the work function, then only the electron emitted. This is the basic criteria. Provided the basic criteria is fulfilled, the intensity, if intensity increases, that is number of photons incidents on the incident metal increases, the photo current increases. How it increases means the intensity is directly proportional to number of photoelectrons emitted. So intensity means number of photons per unit area in given time. If number of photons increases, number of photoelectrons emitted also increases, which in the sense increases the photoelectric current. So intensity is directly proportional to current. So are we clear? That is intensity is directly proportional to number of photoelectrons emitted, it is directly proportional to photoelectric current. So this is the basic criteria. I think you clear with this concept. Then coming to increasing the intensity and compare with this stopping potential. So increasing the intensity, we already deal with this linear proportionality curve. So when increasing the intensity, current increases. This is the saturation current, that is a constant current. When we increase the intensity, the maximum photoelectrons attained here is this flat curve. When increase the intensity again, it will attain maximum intensity, because when we increase the intensity, the number of photons emitted increases, but the collector plate potential, that is anode potential, is the collector plate potential. That if you increase the collector plate potential, the current always remains same. Why it is remains same means the photoelectrons emitted is constant for a particular intensity. If I1 is a particular intensity, it is less than the I3, means I1 emits 10 electrons and the current is something 10 for the 10 electrons, and I3 is 20 electron, means the current is different for 20 electrons. So that is when we increase the collector plate potential, the current remains same, because emitted electrons are same for a particular intensity. If you increase the intensity, electrons increases, then current is different for different intensities. So I3 intensity is the greatest intensity and I1 is the less intensity. So according to that, we know the relation I1 less than I2 less than I3. So as the current, saturation current, I1 current less than I2 current less than I3 current. So intensity is directly proportional to current produced or number of photoelectrons produced. So what is the stopping potential means? If the electrons are emitted, so we have to stop the current means we have to apply negative potential to the anode or retarding potential, so as to stop the electron in collecting by the anode or binding with the anode. For that, if we apply negative electron means the electrons are repelled. For example, take 10 electrons. 3 electrons are fastest electron, 2 electrons are slowest electron, the remaining 5 are medium electrons. So if we apply a small negative charge to the anode, negative potential to the anode, suddenly the 2 electrons, very slowest electron, repelled back. And if you increase the negative retarding potential to the anode, again the medium speed electrons are get repelled, but the fastest electron always come because it has the fastest kinetic energy, more energy. So we should apply more potential, negative potential to the anode, so as to repel that fastest electron. So that is the kinetic energy maximum equal to stopping potential. So stopping potential always remains constant because there is no change in energy or speed of the electron. Only there is a number of photoelectrons emitted or increases, not the energy. Intensity does not increase the electron's energy or speed or kinetic energy. It only increases the number of photoelectrons emitted. Because we know that in Einstein's photoelectric equation, energy of the incident light is proportional to kinetic energy, not intensity. Intensity does not have any dealings with the kinetic energy. Only it increases the number of photoelectrons emitted, in the sense increases the photoelectric current. Whereas the incident light energy or frequency increases the kinetic energy. So stopping potential does not depend on the intensity. It depends only on the frequency. We will see. So in this curve, you can appreciate here, for different frequencies nu1, nu2, nu3, the same current, saturation current is same because number of photons emitted are same, because intensity is made constant here. And also here all the basic criteria are fulfilled. Instantaneous emission and there is no loss of energy, total momentum and kinetic energy conserved, but no number of photons may not be conserved. And the basic criteria is, we know for photoelectric effect, the incident energy, light's energy must be greater than the work function. This is the basic criteria, provided that if we increase the frequency of the incident light, the stopping potential increases, because we know that E is equal to work function plus kinetic energy. E is incident light energy, nothing but frequency. If you increase the frequency, incident light energy is also increases, and it increases the kinetic energy, not the work function. Work function is always constant. For above the work function, the remaining energy always goes to the increasing the kinetic energy or increasing the speed of the electron, photoelectron emitted. So if I increase the frequency, the speed of the electron increases. So to stop the speedest electron, the stopping potential also increases. So for increasing frequency, for nu1, V01 is the stopping potential. Negative denotes the negative potential given to the anode, that is opposite potential. Magnitude increases, direction is opposite. So nu2 is the greatest frequency than the nu1. So as the stopping potential increases, V02, and nu3 is the greatest of all frequencies. So as the stopping potential V03. So for increasing the frequency, stopping potential increases. So how we increase the frequency? Increasing the incident light's frequency, photoelectron speed increases, and also the stopping potential. So the relation is frequency of the incident light is directly proportional to kinetic energy or speed of the electron, or is directly proportional to the stopping potential. So we already saw kinetic energy maximum is equal to EV0, that is stopping potential energy. So we can also say like energy of the incident light is directly proportional to frequency. It is directly proportional to kinetic energy or speed of the electron is directly proportional to stopping potential. So we can derive the relations, and this based upon these relations they will give you a graph and find out which metal has the highest electron emitted or highest photoelectric current produced. They also can ask questions like they will give work function of two materials and the incident light wavelength. We have to calculate incident light's energy from that wavelength and find out the work function must be greater or lesser than the incident energy. Then we have to calculate which metal emits photoelectrons. So we will see this kind of problems in the next class. Then coming to wave nature of the light. So de-Broglie proposed the wave nature of the light by giving first electrons. He proposed the wave nature. So wave nature is nothing but when a particle travels with the speed of light or high speed, it behaves as a wave. So lambda is the wave nature, that is wavelength of the wave nature of the light is equal to h by p. Here de-Broglie says for about For electrons, he said he proposed a theory for electrons. So lambda equal to h by p. P is the momentum of the electron, mv or momentum of the particle, m mass into velocity, h is the Planck's constant, universal constant, 6.626 in 10 to the power of minus 34 joules second. So we can also rewrite as lambda equal to h by root of 2 mev. How we can rewrite means, we know that kinetic energy equal to half mv square. Half mv square, p equal to mv we know. So half mv square is equal to p square by 2m. Also kinetic energy is equal to stopping potential ev. So kinetic energy equal to ev is equal to p square by 2m. p square by 2m equal to ev. p square is equal to 2m into ev. p is equal to root of 2m ev. That's why we substitute here. So lambda equal to h by root of 2m ev. So relation is kinetic energy is equal to half mv square is equal to p square by 2m is equal to ev. Then we know the constants are values for mass of electron and electron energy and h value. So on substitution we get this numerical value 1.227 by root v or 12.24 divided by root v Armstrong. So you should consider about this units and all, nanometer, Armstrong. Then velocity, we can rewrite this formula as velocity. For velocity's sake, h by mv is equal to h by root of 2 mev. So we can reshuffle and realign it as v is equal to root of 2 ev by m. And these are the formulas they will ask for questions. Likely this number of photons emitted per second. Number of photons emitted per second means, if you consider a lamp or any bulb, it emits white light or something. So we know the light's wavelength for particular light. So for sodium light, the wavelength is something 500 Armstrong something, 5000 Armstrong. So we know that light's wavelength, we can calculate its energy from that wavelength or frequency, whatever they will give. So if we can consider the energy of a single photon, we will consider that light emitted from the lamp has a power source like watt. So they will give the source's power, total power in the sense total energy in SI unit, that is watt. So total energy they will give, and also we know the energy of a single photon by calculated from the wavelength or frequency, whatever they given. So total power by single energy is equal to number of particle emitted or number of photon emitted. So number of photon emitted per second is equal to n is equal to total power of source in watts divided by energy of single photon. So energy of single photon can be calculated by either wavelength or frequency, whatever they have given means. So n equal to power of source by energy of single photon. So that's all. So this question they will ask in frequently many exams. So to propose to study the wave nature of light as proposed by de-Broglie, Davisson and Germer performed an experiment. This is the experimental setup of them. So this is a vacuum chamber consisting of electron emission. So how is the electron emitted means by heating the filament. This is the cathode filament. The electron emitted by heating the filament by applying a voltage rheostat and all. Battery. So heating in the filament emits electrons. It is accelerated by potential driven accelerator. It accelerates and produces the electron beam, and it hits the single nickel target, and deflected the electron. The deflected electron are collected by the movable detector. It is connected to the ammeter or galvanometer. The deflection of ammeter or galvanometer produces it is the actual portion of the current produced, or we can say theta is the deflection of the electrons. This is the deflected electron beam. So what they said, like Davisson Germer said means, for 54 volt, for potential of 54 volt, they observed that the diffraction intensity is maximum interference at theta equal to 52 degree. So for 54 volt, they observed the diffraction intensity is maximum for interference at theta equal to 52 degree. Okay, you should know that. So this is the Davisson Germer experiments short explanation. And we know the formula for detecting voltage and all. So relating wavelength and voltage, we know the formula lambda is equal to 12.24 by Armstrong by root voltage. So if they ask any question regarding how to calculate wavelength from voltage means, you can know. So that's all. At least one question will be asked in every entrance examination. So Daily nature, it's an easy topic. This is the basic formulas I already said. If you have any doubt, go and read for H.C. Verma, any objective physics by D.C. Pandey, and your stateboard syllabus or NCERT CBSE syllabus. Whatever book you have, you should read to clarify the basic knowledge. Then go to for different books, and also you should practice many questions as far as possible. Reading alone doesn't help with the how to solve problems. Doesn't help for time management. You should practice as many questions as possible to manage time, and for better understanding purpose also you should learn to solve problems, because solving problems is different from reading. Just reading is just mug-upping, and reading you should know many problem solving skills, and then only the formula can be applied for different different problems. Thank you.